Hello everyone! Today's lesson is about adding integers. Let's start with a short story. May, after missing her friends for several days, decided to visit them after her vacation abroad. Her friend Louie lives 5 blocks west of their home, while Danica lives 4 blocks west of Louie's home. How far is May from her home if they are now at Danica's place? Let us answer this problem using a number line. Again, we are asked to find how far May is away from her home if they are now at Danica's place. So we have here the keyword from her home, which tells us that this will be our reference point. So using a number line, we'll have May's home as the reference point, and it will be located at 0 on the number line. In the problem, we're also given that Louis' home is 5 units to the left of May's home, while Danica's home is 4 units to the left of Louis' home. So, if May will go to Louis' place, which is 5 units west of her home, she will now be at -5 on the number line. And from Louis' home, if they go to Danica's home, which is 4 units west of Louis' home, they will now be at -9. Therefore, May is 9 units west of her home. Let's try another one. Anna sits on the second chair south of Joyce. Cherry sits on the fourth chair south of Anna. How far is Cherry from Joyce? Again, we will use a number line to answer this problem. So we are given here from Joyce. So our keyword is from. Therefore, our reference point will be Joyce's seat. Again, we will be looking for the distance of Cherry's seat from Joyce's seat. So using the number line, we'll have Joyce's seat as the reference point, and again, it will be located at 0 on the number line. In the problem, we are also given that Anna's seat is 2 units south of Joyce. So that will be at -2 on the number line. And lastly, we are given that Cherry's seat is 4 units south of Anna. So if Anna's seat is at -2 and you count 4 units below, then Cherry's seat is at -6 on the number line. That means the distance of Cherry's seat from Anna's or Joyce's seat is 6 units. Now, how do we add integers using a number line? When adding integers using a number line, first we locate the first addend in the number line. Then we jump on the left if we are adding negative integer, and we jump to the right if we add positive integer. Let's have some more examples to understand this better. Say for example, we are to add -4 and +3. Using the number line, first we will locate the first addend, which is -4. So -4 is here on the number line. Then we will be adding a +3. Since the second addend is a positive number, then we will jump to the right on the number line. And that will be 3 units to the right. So if we'll count 1, 2, 3 units to the right, we'll end up at -1. Therefore, -4 plus 3 is equal to -1. Next, -3 plus 5 equals n. Again, we will locate first the first addend on the number line. So -3 is here. We'll be adding a +5, so we'll jump 5 units to the right. 1, 2, 3, 4, and 5. And we'll end up at +2. So that means -3 plus 5 is equal to a +2. Another one, 5 plus -10 equals n. Let us locate 5 on the number line, and 5 is here. We will be adding a negative 10 to our positive 5, so that means we will be jumping 10 units to the left since 10 is negative. From 5, we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left, and we'll end up at negative 5. So 5 plus negative 10 is equal to a negative 5. Okay, next, negative 6 plus negative 2 equals n. Again, we will locate the first addend on the number line, and negative 6 is here. We'll be adding a negative 2, so that means we'll be jumping 2 units to the left on the number line from negative 6. So we have 1 and 2, and we'll end up at negative 8. Therefore, negative 6 plus negative 2 is equal to negative 8. Another one, negative 2 plus negative 8 equals n. Negative 2 is here. Then we'll be adding negative 8 to it. So we'll be jumping 8 units to the left. We have 2, 3, 4, 5, 6, 7, 8. And that will be equal to a negative 10. Now let's try some more examples. A cyclist cycled 8 kilometers north of Manila. If he traveled back 5 kilometers, how far is he from Manila? So we have here the keyword from, Manila. So our reference point will be Manila. According to the problem, the cyclist cycled 8 kilometers north. Since we have the keyword north here, it means that this 8 is a positive integer. After that, he traveled back 5 kilometers. So if he traveled north 8 kilometers earlier and he traveled back 5 kilometers, it means that this 5 here is represented by a negative 5 integer. This time, we'll be using colored chips to answer that problem. Okay, so take note that a pair of positive and negative integer is called zero pair. That means when you add a positive and a negative integer, they cancel out each other. For example, if you have one yellow chip and one red chip, that means 1 plus negative 1. It is a zero pair, so that will be equal to 0. Another example is if you are going to add positive 4 and negative 4. So positive 4 and negative 4 will form 4 pairs of zero pair. That's why when you add 4 and negative 4, that is equal to 0. So let's go back to our problem. According to the problem, the cyclist cycled 8 units north of Manila. So it will be represented using 8 yellow chips. Then he traveled back 5 units from his current position. So it will be represented using 5 red chips. Now, in adding integers using colored chips, again, always take note that each pair of a yellow chip and red chip makes a zero pair. So let's look at all the pairs or zero pairs that we will make out of this given. So we have 1, 2, 3, 4, and 5. And all these 5 pairs are equal to 0. Therefore, when you add 8 and negative 5, the answer is equal to 3. Let's have some more examples. Okay. Negative 8 plus negative 2 is equal to n. Using colored chips, negative 8 will be represented using 8 red chips. Then if you are going to add 2 or negative 2, that will be 2 more red chips. So all in all, you have 10 red chips. Therefore, the answer is a negative 10. Next, negative 3 plus negative 5 equals n. So we have negative 3 is represented by 3 red chips. If you're going to add 5 or negative 5, then you will have 5 more red chips. So all in all, you will have 8 red chips, which is equal to a negative 8. Next, 6 plus negative 3 is equal to n. 6 is a positive integer, so it will be represented using 6 yellow chips. Then if you will add negative 3, which is represented by 3 red chips, you will get 3 zero pairs, which is again equal to 0. Therefore, 6 plus negative 3 is equal to a positive 3. Another one, negative 6 plus 10 is equal to n. Negative 6 is represented by 6 red chips. And if you're going to add 10 or positive 10 to it, you'll have 10 yellow chips. And from this given, you'll be able to make 6 pairs of zeros. Therefore, you will be left with 4 yellow chips, which is equal to a positive 4. Now, how do we add integers without using a number line and colored chips? Based from all the examples we had earlier, in adding same-signed integers, we simply add the digits and copy the common sign. For example, if you have 5 plus 7, that is equal to 12. Another one, if you have a negative 5 plus negative 7, you just simply add the digits 5 plus 7, that is equal to 12, and you copy their common sign. Since both of them are negative, then the sign of your sum is also negative. On the other hand, if you're adding different signed integers, we subtract the digits and copy the sign of the integer with a greater absolute value. For example, 5 plus negative 7 is equal to a negative 2. Again, since 5 and negative 7 are different signed integers, we subtract the digits. The difference between 5 and 7 is 2. Then, the absolute value of 5 is equal to 5, while the absolute value of negative 7 is equal to 7. Since negative 7 has a greater absolute value, we follow its sign. That's why the sum is a negative integer. Another one is if you are adding negative 5 and positive 12. That is equal to 7. Since they are different signed integers, you simply subtract the digits, and the difference between 5 and 12 is 7. But since positive 12 has a greater absolute value, we follow the sign of positive 12. That's why the sum is a positive integer. And that's it for our lesson for today. Thank you for listening.